So looking at the balancing of chemical reactions, remember that we have to do this because of the law of conservation of mass. Whatever goes into a chemical reaction comes out. It's in a completely different form because bonds are broken and rearranged and new ones are made, but whatever goes in has to come out. So basically this is chemistry accounting. Here we see the formation of sodium chloride from sodium and chlorine. Sodium is a monatomic element, chlorine is a diatomic element. So if balancing isn't your thing, or you struggle balancing equations, or if you come across a challenging equation to balance, you might want to make yourself one of these little charts where you take what's in the reaction. Here we have sodium and chlorine, and you can make a little tabulation of what's going on with the reactants and products. So right now, going into the reaction, I've got 1 sodium and I've got 2 chlorines. Coming out, I've got 1 sodium and 1 chlorine. So this is not a balanced equation. Now, you might say, oh, okay, well, I'll just put a 2 here and fix that. And that is wrong. Okay, we don't toucheth the formulas. Once we have a correct chemical formula, that doesn't change. All that we can do to balance the equation is use coefficients in front of the formulas. So if I have 2 chlorines going in, the only way that I can make 2 chlorines come out is to put a 2 here. And that does wonders. Now we do have 2 chlorines coming out. However, this 2 also makes 2 sodium come out. But not to worry, that just means we have to go back over to the reactant side and fix that situation. And so now we have 2 sodiums going in and out as well. So this is a balanced equation. And typical of balancing equations, you fix one thing and you got to fix another. There's no specific set of instructions to follow. It's problem solving, it's solving a puzzle, stuff that we've been working on all year long, getting better at. And I'm just going to show you a couple more examples with a couple more hints and helpful tools that you might find to be useful when balancing. Here we see potassium perchlorate breaking down into potassium chlorate and oxygen. And by the way, I'm taking all of these examples from that description page of your different types of reactions. So if you're looking where I got these from and you're one of my students, that is where I got all of these sample problems to balance on the types of reactions description paper that I gave you. So again, I am looking at figuring out how many potassiums, chlorines, and oxygens are on both sides. So if I'm doing my tabulation, 1 potassium and 1 chlorine are going in, as well as 4 oxygens. Coming out, 1 potassium, 1 chlorine, and then I have 3 plus 2, which is 5 oxygens coming out. So there's where our imbalance is. One thing I noticed about this reaction is I can only put oxygens in packages of 4. So coming out on the product side, I must have 4 oxygens, or 8, or 12, or some multiple of 4. And typically, if I have an odd even situation like that, one of the things that tends to help is what I call doubling the recipe. If I put a 2 here, since 1 potassium perchlorate is not balancing this equation, by putting a 2 there, that will make 2 potassiums going in, 2 chlorines going in, and 2 times 4, 8 oxygens going in. So now I need to check the product side and see how this remedied the situation. Well, I'm going to have to put a 2 here because I do need 2 Ks to come out as well as 2 chlorines to come out. So what does that do to my oxygens? 2 times 3 is 6, plus 2. Hooray! That makes 8 oxygens, and this is a balanced equation. Let's look at this single replacement example. Here I have cadmium and phosphoric acid reacting to make cadmium phosphate and hydrogen. My one big hint here, well, actually two big hints. If I have a polyatomic ion on both sides, make it stay as one thing that you're keeping track of. Don't make it harder on yourself, and keep track of cadmium, hydrogen, phosphorus, and oxygen. Just keep track of cadmium, hydrogen, and phosphate. Now sometimes the polyatomic ion will come apart or be built in a reaction, and then you can't do that. But if you see the polyatomic ion on both sides, keep it as one entity. And then my second hint is start by trying to fix that polyatomic ion. So going in, I've got 1 cadmium, 3 hydrogens, and 1 phosphate. Coming out, I have 3 cadmium, 2 hydrogen, and 2 phosphate. So if you follow my advice and try and fix the phosphates first, that usually gives you an easier path to the finished product. So with 2 phosphates coming out, I'm going to have to put 2 going in. So I fix that problem, but now that makes 6 hydrogen that are going in. But that's okay, no fear. Let's go and fix that over here, and I'll put a 3, and that will make 6 hydrogen coming out. Now the only thing left to fix is cadmium. Since 3 are coming out, I just need to put a 3 here, and that will make 3 go in, and everything is balanced. Looking at the double replacement example here, again I see that I have carbonate on both sides, so I'm going to treat it as an entity. And why don't you take 2 seconds here and see if you can balance this on your own. Looking at what we have to start though, if you'd like. Going in, there's 2 potassium, 1 carbonate, 1 aluminum, and 3 bromine. Coming out, I've got 1 potassium, 1 bromine, 2 aluminum, and 3 carbonate. So again, give yourself a chance and pause the video and see if you can balance that, and then check it. So if you took my advice to fix the carbonates first, 3 going out is going to make me put 3 in. That makes 6 potassium, so I'm going to have to put a 6 here. But that makes 6 bromines, so I'm going to have to put a 2 here. That makes 2 aluminums, which is what is coming out. So we see we have everything balanced. 6 potassium in and out, 3 carbonates, 2 aluminums, and 6 bromines. Combustion reactions can get a little tricky. The numbers can get a little high, and typically I like to use these for like bonus questions. But there is a pattern that I like to follow that tends to be successful for balancing combustion reactions. Every combustion reaction is going to involve carbon, hydrogen, and oxygen. In this reaction here, I've got 4 carbons going in, 10 hydrogens going in, and 2 oxygens going in. Coming out, 1 carbon, 2 hydrogen, 2 plus 1, that's 3 oxygen. And so what I like to do is just start with the carbon and fix that, then fix the hydrogen, and worry about the oxygen. So if I have 4 carbons going in, I'm going to put a 4 here, try and fix that. 10 hydrogens going in, 5 times 2 is 10, so I'm going to put a 5 here to fix that. So now let's check our oxygen. 4 times 2 is 8, plus 5 makes 13. Wah wah. Oxygens can only be in an even package, an even number. And so if you remember the last time we came across that, we want to do the doubling of the recipe. So if I double my recipe, that's going to make 8 carbons go in. I'll fix that by putting an 8 here. 8 carbons come out. That makes 20 hydrogens going in, So to fix that, I'm going to put a 10 here, because 10 times 2 is 20, and now I have 20 hydrogens coming out. Now with the oxygens, 8 times 2 is 16, plus 10, that makes 26. And if you remember, before we doubled the recipe, we had 13 oxygens over here, and that lucky number ends up right here to give us our proper amount of oxygen. So again, do the carbons, then the hydrogens, and work on the oxygens. If it works, great, and you can put it, there's an even number of oxygens coming out, then you can just balance right away. If it's not, double the recipe. So there's one more example on that paper I gave you, and here we see the combustion of pentane, and so give that one a try and see if you can balance this. Pause the video and then I'll show you the answer. So here you see the answer. It was another double the recipe, and when I do that I can get 10 carbons in and out, 24 hydrogens in and out, and 22 oxygens in and out. Again, when doing this, a lot of these equations are going to be potentially simple to solve by just eyeing them or using one number here or there. This chart, that is if you're struggling with balancing, or perhaps you just struggle with a equation of reaction to balance because it just has some polyatomic issues or going on, or whatever the case may be. Hope this helps you, and talk to you next time.